Dear students, welcome to a session on rolling process. First of all, let us check what is hot working process. Hot working process provide means of producing a desired shape at elevated temperature. What happens when the material is heated or taken to an elevated temperature? The metal become weakened and become more ductile, and recrystallization occurs and deformation takes place. Some of the major hot working processes are rolling, forging, and extrusion. Rolling is a process by which the workpiece is converted to a finished product by passing between the rolls. The workpiece that we use here are known as stock. The stock can be named as blooms, billets, slabs, or any other shape. Apparently all are same, but depends on the shape and size, the stocks are named variously. A bloom has a square or rectangular cross section with a thickness greater than 6 inches and a width no greater than twice the thickness. A billet is usually smaller than a bloom and has a square or circular cross section. A slab is a rectangular solid where the width is greater than twice the thickness. Sheets and strips can be converted into foils. Blooms and billets, they are rolled into finished products and used to produce structural shapes such as railroad or bar, rod, tube or pipes. This is a figure showing how the slabs are converted to plates or sheets are converted to large diameter pipes, how blooms are converted to railroads and structural shapes, then billets are converted to bars or wired rods. All the details you will study in the coming classes. A rolling process is deforming the metal into semi-finished or finished condition by passing the metal piece in between two rollers. Here we can see there are two rollers rotating in opposite direction. The stock has an initial thickness of H0 and a width W. It has a initial velocity of V0, and when they are passed in between the rollers, the velocity becomes Vf and the final thickness becomes Hf. There are two rolling process, hot rolling as well as cold rolling. In hot rolling process, the material is shifted to an elevated temperature where recrystallization takes place and the rolling process happens. In cold rolling, the rolling process happens at the room temperature. We can see in the figure how the grain structure has changed in both hot rolling and cold rolling process. Hot rolling process is prominent among all manufacturing processes. It's a standardized process. We obtain standard shape and size using hot rolling process. Let's see how the basic rolling process takes place. There are two rolls rotating in opposite direction. The heated metal, as it's a hot rolling process, the heated metal is passed between the two rolls. The gap between the rolls is less than the thickness of the entering metal. The rolls rotate with surface velocity that exceeds the speed of incoming metal. Friction along the contact surface acts to propel the metal forward. We know the roll's velocity will be greater than the speed of the incoming metal, and the friction between the rolls and the metal piece makes the metal move forward. When the metal piece is passed between the rollers, the metal is squeezed and they elongate, which result in decrease of cross-sectional area. The amount of deformation in a single pass depends on the friction condition along the interface. If too much material is demanded, the rolls cannot advance the material and simply skid over its surface. This is a schematic representation of hot rolling process. Here we can see the two rolls rotating in opposite direction. The metal piece is passed between the rollers. The metal piece has an initial structure as shown in the figure, and when they are passed between the rollers, recrystallization occurs and the grain structure is altered. The temperature of the metal piece used for rolling, or the stock that is used for rolling, is very crucial. If the temperature is not uniform, the deformation also will not be uniform. Let's see what are the various roll mill configuration. We can see the first figure, it's the two high non-reversing structure. Here there are two rolls, as we said earlier, rotating in opposite direction, and the steel is passed between the rollers. And the second figure, there is two rolling mills and they are reversing. That means the roll distance or the distance between the rolls can be adjusted. At first, the roll allows the metal to move from left to right, and once the whole metal is traversed, the roll gap is adjusted and it's made to move from right to left, that is in the reverse direction, so that further deformation can be attained. Then the third figure is three high rolling mills where there are three rolls. Carefully look at the directions. The bottom two rolls, they are rotating in the opposite direction, and the above two, that means the subsequent rolls should rotate in opposite direction. So first the metal piece is moved between the first two rollers, and again the steel is returned through the above two rollers. That is the working of three high rolling mill. And next is four high rolling mills, in which there are four mills or four rolls, and the smaller rolls, they are the actual rolling mills, and the bigger ones, they are used as backing rolls or support for the other small rollers. The working is similar to the two high non-reversing mill. And next is cluster mills. There are more number of backing rolls. Carefully look at the directions of various rolls. The two rolls which are coming in contact, they should have the opposite direction. So while marking the direction, please be careful. Now let's check what are the basic rolling operations. There are mainly two rolling operations. First one is flat rolling and the other is shape rolling. As we all know, the workpiece is passed between the set of rollers and the compressive force is applied. When these compressive forces reduces the thickness of the work material, it is known as flat rolling, and when they are changing the cross section, it is known as shape rolling. Let's see some of the rolled products made of steel. Earlier we studied that there are mainly three types of workpieces or stock. They are bloom, slab and billets. The bloom is converted to some structural shapes as well as for rails. The slabs can be converted to plates or sheets, and they can be even converted to coils. Billets are converted to bars and rods. Now let's look at the shape rolling process. Primarily, the shape rolling process can be accomplished by passing the work through rolls that have the reverse of the desired shape. Once again, it's passed between the rollers that have the reverse of the desired shape. We can see here the bloom and the billets. It's converted, just look at the first figure. The bloom is converted to structural shape. How? We can see the structural shape like an I section. It's passed between two rollers which is having the reverse of the desired shape. Similarly, rails as well as bars, all those are produced using rollers which have the reverse of the desired shape. The products that can be made through shape rolling process are construction shape like I-beams, L-beams, U-channels, rails for railroad tracks, round and square bars and rods. Now let's study the thread rolling process. Threads are formed on cylindrical parts by rolling them between two thread dies. Here, see the figure, we are using through two thread dies. One is a fixed die and other is a moving die. The blank, that is the starting blank, which does not have any impression, it is passed between the fixed die and the moving die. The thread that has to be engraved on the blank is shown on the die. So when the moving die rolls over the fixed die with the blank in between, we can see the finished part is produced. This is how the thread rolling process takes place. Let's see the advantages of thread rolling. They have higher production rates, better material utilization, stronger threads and better fatigue resistance due to work hardening. Do you know what is work hardening? Work hardening is a step in which the material is hardened due to the repeated works on the workpiece. Rolled threads are produced in a single pass at speeds far in excess of those used to cut the threads. The resultant thread is very much stronger than the cut thread. These are the major advantages of thread rolling. Next one is an important topic, which is a ring rolling process. A ring rolling process is the deformation process in which a thick walled ring of smaller diameter is rolled into a thin walled ring of larger diameter. That is, see the first figure, it's a ring which is having a thick wall. That means the thickness of the ring is high and it's having a smaller diameter. It is passed between two rollers. That is, one is a main roll, it's providing the feed, and the second one is idler rolls. And here we have two edging rolls which is used to support the workpiece and provide the sufficient thickness for the finished product. So once the rolling process happens, the diameter of the ring increases and the thickness reduces. That means the thick wall of smaller diameter is rolled into a thin wall of larger diameter. In the figure there are two rollers used. One is the driven roller and other is the idler roller. The idler roller rolls, or it's driven by the surface friction of the running, and the driven roll is the main roll. that rolls either by a machine drive or another separate motor. Let's see the applications of ring rolling. It's used for making bearings, steel tires for railroad wheels, ring for pipes, pressure vessels, rotating machinery. It's used to reduce the wall thickness and increase the diameter of the ring. It's also used for tube rolling process. Next is gear rolling process. It is similar to thread rolling. Here a gear profile is produced. It's mainly a cold forming process. That means it takes place at the room temperature. Here you can see the figure that a impression of gear is produced using the gear rolling process. Next we can go to the tube rolling process. It's a process used to reduce the diameter and thickness of the pipes or tubes. Let's go to the figure of tube rolling process. Here we have the tube here we have the solid rod which is to be converted to a tube. We have two rollers here. We can see the third figure. We have two conical rollers. In between the solid rod is compressed. We have a mandrel which is creating the hole in between the two rollers. So primarily what we are doing is a small punch is made at the center of the solid rod. Once the two rollers create a compressive force on the solid rod, the cavity begins to enlarge. Here the mandrel is inserted to the solid rod and the tube is formed. The figure we can see the mandrel is drilling the hole and producing the tube-like structure. The tube rolling process, otherwise known as roll piercing, is used to make seamless pipes. Here, as we told earlier, the first stage is producing a hole or creating a punch of predetermined depth on the solid rod. The mandrel is placed inside the workpiece and is placed between the conical shaped roller dies and is rolled. Now let's study what are the defects in rolled products. The major defects are cracks, uneven deformation, waviness, inclusions. And all these above said defects come under the main three categories. First one is defects due to roll gap. Second, inhomogeneity in deformation. Third one is defect introduced during the ingot stage. The first one is defects due to roll gap. That means if the roll gap, that is the gap between the two rollers, if that is not parallel, non-uniform roll products can be produced. Because of the tendency of the rolling or due to rolling pressure, there may be non-parallel roll gaps. This may lead to waviness defect or edge buckles. So the roll gap of the two rollers must be parallel, and the rolling speed is also very much sensitive to the flatness of the product. Next is inhomogeneity in deformation. These result in defective shape and flatness of the roll product. There are mainly two types of defects caused due to inhomogeneity. First one is edge cracking and the second one is roll deflection. In edge cracking, due to friction effect, the sheet undergoes more deformation in the center than at the edges. The edges get more strain and causes cracks at the edges. Next one is roll deflection. Due to the rolling forces or rolling pressure, there are chances of the rolls being bent elastically, and this result in thicker parts at the center. You can see in the figure A. The figure shows some of the defects in flat rolling. The first figure shows wavy edges. Earlier we discussed about the wavy edges. Second figure shows zipper cracks in the center of the strip. There are small cracks at the center of the strip. Third one is edge cracks. The cracks are formed at the edges. And the fourth one is known as alligatoring. That is, a shearing occurs on the rolled surface and it looks like the mouth of an alligator. That is why it's known as the alligatoring. Also, defects are caused due to the defects of the workpiece or the stock material at the ingot stage. That is due to the defects of the raw materials.